Chapter 9. Land, Soil and Water. Reading objectives. Various types of natural resources. Land and its types. Soil and its formation. Types of Indian soil. Soil conservation method. Water and its conservation. A resource fulfills human needs. That's why a balance between population growth and the utilization of resources is definitely necessary. Among the land, soil and water are main natural resources. Land, soil and water are three main natural resources. Our life depends on these natural resources, directly or indirectly. We need to utilize these resources in the best manner. If we overuse or misuse them, a time may soon come when life on the earth will become impossible. Let us see how these resources are distributed on the earth's surface and their pattern of use. Since these resources are available in a very limited quantity, the ever-growing population has too much of pressure on these natural resources. It is subject of management of these precious resources that should worry man today. If managed with efficiency, natural resources have a long-term sustainable potential for sustaining the increasing population of the world. Enrich yourself. Conserve rainwater or rainwater harvesting. Restoration of traditional ponds, tanks and lakes to store the rainwater. Allow percolation of water into the ground by constructing dams. Leveling, bonding, contour plowing and terracing in the fields to control runoff. Water harvesting is a technique by which the recharge of groundwater is increased. This is done by capturing and storing rainwater locally in subsurface water reservoirs. Households can meet their water needs by the rainwater harvesting. Plantation of trees and other vegetation to control and thus let rainwater sleep down. Conserve domestic water. Turn off the tap while brushing your teeth. Mend leaking taps. Reduce your shower time. Don't leave the water running while washing dishes or clothes. Water your garden early in the morning or late in the evening to prevent evaporation. Use mulch between plants and trees. Land resources. Land is a major form of the lithosphere. It provides most of the substances which are necessary to support life. About 1/5 of the Earth's surface is land. It is estimated that the total land on the Earth measures about 13,393 million hectares. The rest is covered by oceans and seas. Of this land, only a fraction is habitable by humans. The rest is made of vast deserts, dense forest and rugged mountains. The rocky slopes of the mountains, low-lying areas prone to floods during rainy seasons, dry and sandy desert areas, regions covered by continental and mountain glaciers, and thick forested areas are generally populated or uninhabited. In fact, 90% of the world's population lives on just 30% of the land area. Plains and river valleys provide suitable land for agriculture. They are also easy to build on and live in. Thus, these are thickly populated areas of the world. Classification of land. Land can be classified on the basis of relief, as plateau, plains and mountains. Soil fertility, as fertile and barren land. Development of that area, as rural and urban land. Ownership of the land, as private land and government or community land. Private land belongs to an individual. Community land is owned by a group of people in a community for common use such as collection of fodder, fruits, nuts or medical herbs. These lands are also known as common land or common property resources. The use we put it to, as arable land, i.e. land which is suitable for crop production, pasture land, land for grazing animals, forests, fallow, land for cultivation, but has been left unused for the seasons, cultivable waste i.e. land for cultivation but which has been lying fallow for more than 5 years, and non-agricultural land. Land use. Land is used for different purposes such as cultivation, grazing, mining, setting up of industries, settlements, and so on. Such land utilization is called land use. The land use is directly linked with the economic activities. These economic activities lead to several problems in the environment. These problems concern the discharge of pollutants, disposal of wastes, consumption of natural resources, etc. The amount of land used for a specific purpose varies from one region to another. It also different from time to time in the same region. Physical factors, like relief, climate and soil put certain limits on land use. For example, a forest cleared for use as an agricultural land has a far-reaching influence on the tourism and wildlife of the area. Again, changes also result from one land use to another. For example, agricultural land is used as an urban area, or for forestry. These changes are necessary to get more and more economic benefits from the land. But these changes also create many problems to the environment of a place. There can be negative impacts on water cycle, on surface water, wildlife and soil etc. Land use in India. The pattern of land use is broadly distributed as follows: snow area 46.6%, land for permanent pastures 3.6%, forest land 22.6%, cultivable waste land 4.5%, non-agriculture 13.5%. Get to know more. The records of population density 2011 of India state that the density 2011 has increased from a figure of 324 to that of 328 per square kilometer, which is considerably higher than the average population density of the world 2011, which is 46 per square kilometer. Arunachal Pradesh is the state with lowest population density in India, while National Capital Region area of Delhi is the highest density, and state-wise it is Uttar Pradesh, according to the census 2011. Degradation of land. Urbanization is the main cause of degradation of land. Vast areas of forests are cleared to accommodate the ever-growing population of humans and to bring under cultivation for producing food to feed this huge population. Soil erosion also takes place when forest cover vanishes from land. Shifting cultivation and desertification also add to the degradation of land. Land conservation. To ensure that natural resources are not depleted and to maintain ecological balance, the present rate of degradation of land resources must be checked. Afforestation, land reclamation, regulated use of chemical and pesticide and fertilizer, planting of shelter belts, controlled mining and checks on overgrazing are some of the common methods used to conserve land. Soil resources. Soil can be defined as the uppermost layer of the crust of the earth, which permits plants and other organisms to grow in it. The decomposition of dead organisms also takes place mostly in the soil. Soil is also found in the bottom of water bodies, rock surfaces and glacial deposits, etc. Soil is available up to the depth of 1 to 3 meters. Composition of soil. Since soil is a product of complex interaction between environmental factors and living and non-living matters, it contains both living and non-living components. The major components of soil are as follows, shown with the help of pie chart. Water, 30%. Air, 20.4%. Living organism, 0.1%. Organic matter, 2%. Mineral matter, 47.5%. Mineral matter is the resultant product of the initial breakdown of rock. Humus is the addition of organic matters from the decomposition of dead organism. This makes the soil fertile. Water molecules are also present in the soil. These molecules are located in the minute pores produced by the soil particles. Water has major nutrients needs for plant growth present in it. The pores in soil which are free of water molecules have air in them. The air in the soil is principally controlled by carbon dioxide. No soil is free from the presence of living organism, but their intensity varies from soil to soil. This includes bacteria, fungi, algae, protozoa, nematodes, mollusks and arthropods. Soil formation. Soil is formed by the breaking of rocks. The process occurs gradually. The following processes are responsible for soil formation. Relief is the initial step in the soil formation. In this step, the bigger rocks are broken down into smaller mineral particles. It is done by the action of water, temperature, glacier and gravity, etc. The steps included in this process are wetting, drying, heating, cooling, freezing and glaciations, etc. Parent rock materials are very important in soil formation. Water enters into the rock through the cracks and the rock gets swollen. This swelling results in the breaking of rocks. Certain minerals, like potassium and silicon, are removed from the rock surface by water. These minerals are broken down into simpler particles such as aluminosilicates. In the process, certain chemical substances of a rock undergo reverse reaction. These reactions cause disruption in the rock, and thus the process of breaking is quickened. The stable carbon compounds change into unstable ones. This process also acts as a catalyst towards soil formation because the rock is broken down into pieces and particles quickly. Microorganisms produce chemicals called chelates. These chelates dissolve the mineral components of rocks and thus remove the binding material from them. Pedogenesis process is actually a continuation of weathering. The weathered material undergoes further changes during pedogenesis. The living organisms are mainly active in the process. Their secretion of organic acids, enzymes and carbon dioxide production acts on the rock particles. They bring about various changes in the texture and physical properties of these particles. Soil profile. A vertical section of soil from the surface to the parent rock is the soil profile. The soil shows their organic and inorganic character due to soil profile. The layers or horizons of soil are determined by soil profile. The soil horizons are usually named A, B, C and D from the uppermost layer of the soil to the parent rock below. The soil profile discussed above is represented by 5 main horizons or layers of soil. These horizons or layers vary from one another physically and chemically. These 5 horizons or layers of soils are as follows. Horizon. O is the uppermost horizon or layer of soil. It contains fresh or partially decomposed organic matter. This layer in forest is well developed because of the presence of fallen leaves from the trees. Grasslands have less developed top level of soil. Topsoil, A, is placed just below the total, O horizon. It has abundance of organic matter and is rich in silica. This region is full of humus. The humus is formed by the mixing of organic matter with the minerals present in the rocks. Heavy rainfall causes its color to fade, so it looks light-colored. Subsoil, B, is the layer just below the top soil. It is dark-colored layer. The particles have a coarse texture. It is rich in iron, aluminium, manganese. It has abundance of silicate. But it has only minor amounts of organic matter. Parent material, C, horizon usually consists of loose rock material from which the A and B layer have been formed. This zone has no humus nor does it have any soil structure. Bedrock, R or D, is the region of unwanted rock and is also called bedrock horizon. Water is being collected on this bedrock. The Indian soil. The Indian Council of Agriculture Research, ICAR, has classified the soils found in India into 6 groups. The classification is based on origin, color, composition, texture and location. A. Alluvial soil is a rich and fertile soil formed by the depositional action of rivers. The soil is deposited in these areas by the rivers following them. This fertile alluvial soil supports cultivation of crops. This type of soil forms about 40% of the soil found in India. The plains and deltaic regions of India have abundance of alluvial soil. Punjab is also known as the rice bowl of India. Its plains receive the alluvial soil from 5 rivers that flow through Punjab. The rivers flowing through South India also deposit heavy amounts of alluvial soils, thereby making the area rich in production. B. Black soil is formed by the weathering of the volcanic rocks. The soil is black in color and very porous. It holds much moisture as it is made up of fine clay material. Such soil is suitable for growing cotton and sugarcane. This type of soil is found in the Deccan Plateau in the state of Maharashtra, Madhya Pradesh, parts of Gujarat and Karnataka, Andhra Pradesh, Tamil Nadu, Uttar Pradesh and Rajasthan. C. Red soil is formed by the breaking down old igneous rocks. The redness is due to the presence of iron oxide. This soil is good for the cultivation of oil seeds, wheat, onions and mallets. It is found around the black soil zone in the Western Ghats, eastern Madhya Pradesh, and in parts of Odisha, Andhra Pradesh, and Tamil Nadu. Before crops are sown in the red soil, the farmers use chemical fertilizer and local manures to counteract the effect of iron from the soil. D. Laterite soil is formed because of intense leaching in regions with heavy rainfall. This soil is very poor in mineral content due to the washing away of the fertile part of soil by heavy rains. No significant crops are cultivated in this type of soil. It supports only some types of shrubs, fodder crop, jute, millets. In India it is found in Maharashtra and West Bengal. A. Mountain soil is mainly found on the hill slopes covered with forests. The fallen leaves and decaying vegetation add manure to the mountain soil, making it fertile. However, based on altitude and vegetation, the soils in mountains vary in texture and fertility from height to height. These are found in India, in the Himalayan ranges and the eastern and western Ghats in the south. Slopes are best suitable for the cultivation of tea, coffee and spices. India grows tea in the northeast regions of Himalayas and spices in the southern Ghats. F. Desert soils are sandy to gravelly with low organic content and low nutrients. This soil has very low moisture and humus content, vegetation is normally not possible. However, if water is made available, various types of vegetables and fruits in the dry and semi-dry areas of Rajasthan and parts of Gujarat. The Indira Gandhi Canal project of Rajasthan has converted most of the desert soils into fertile soils. Todi Rajasthan is able to supply fruit and vegetables to most parts of the country. Soil degradation. It is estimated that about 25 million hectares of land throughout the world has turned barren due to soil degradation. More than half of India suffers from one or other form of soil degradation. India has an area of 3.28 million square kilometers. Out of this, 1.4 million square kilometers area has lost its soil. About 270,000 square kilometers are degraded by floods, salinity and alkalinity. An expand estimate states that India loses 6,000 million tons of topsoil every year. Deforestation is another cause of soil degradation. Increasing urbanization and industrialization heavily affects the soil of the country. The main cause of soil degradation is its erosion. Soil erosion. The removal of the top layers of the soil on a large scale by rainwater, wind or humans is called soil erosion. The soil loses its fertility due to erosion. Different physical and cultural factors cause soil erosion. The physical factors are the slope of the land, intensity of rainfall and velocity of wind. The cultural factors are deforestation, overutilization of land, overgrazing and adoption of unscientific farming methods. Soil erosion is a major problem faced in India. The erosion of soil has threatened the life of dams. It is said that slits deposited in the Bahakar Dam due to soil erosion has reduced the life of the dam by 250 years. Soil conservation. The importance of soil conservation has been realized in recent years. It is necessary for increased agricultural production. Measures for soil conservation are based on certain principles of soil conservation. These can be summed up as follows: protection of soil from the impact of raindrops. To slow down the water from concentrating and moving down the slope in a narrow path. To slow down the water movement when it flows along the slopes. To encourage more water to enter the soil. To increase the size of the soil particle. To reduce wind velocity near the ground by growing vegetation cover. To grow strips of such vegetation cover that might catch and hold the moving soil particles. On the basis of the above principles, the following methods of conservation of soil are devised. Methods of soil conservation. Several methods have been suggested for the conservation of soil. These are: contour farming is an old method of soil conservation. The land is divided into ridge, known as contours. The water is hauled into these ridges and stored in grooves. On sloopy lands, the contour farming is attached to terracing. Mulching is effective against wind, and also against water erosion of soil. In mulching, the basal parts of plants called mulchers are used to protect the soil from erosion. For this purpose plants, like maize, cotton, tobacco and potato are grown. Crop rotation also helps conserve soil. The main crop is given a rest and different crops are grown in the same field one after the other so that it restores the soil fertility. Usually legumes, like peas, beans, etc., are sown as rotation crops. Intercropping refers to growing different crops in alternate rows or strips, so that water flow is checked. It may be contour strip cropping, where strips are planted along the contours at 90 degrees to the direction of slope. In dry farming, mainly grazing fields are cultivated. It is practiced in low and moderate rainfall areas. In these areas, ordinary farming runs the risk of failure. In agrostological method, grasses are used as erosion-resistant plants. The grasses are grown in strips between the crops. These grasses help in building up the soil structure, thus preventing soil erosion. Terrace farming is a process in which hill slopes are used as cultivable land. The farmers cut terraces into slopes to create flat areas to grow crops because flat land is scarce in hilly areas. Afforestation is the best way to conserve soil. In order to control the speed of wind, trees are planted in deserts. These trees are called windbreaks. These are planted across 90 degrees to the prevailing winds. They stop the spread of sand dunes. Water resources. Water is the element without which life cannot sustain itself. In fact, life has its origin in water. The word water comes from the Old English weather. In Germany it is called Wasser, Latvians call it Udens, Swedish as Vatten, Indians as Pani or Jal, and so on. At standard temperature and pressure, water is found in the state of solid, liquid and gas, vapors. This is the only liquid having no color, no taste and no smell. Water is referred as the universal solvent, because most of the other substances dissolve in it more easily than in other solvents. It is the only pure substance. Water takes many different forms on the earth, such as water vapor, and clouds in sky, waves and icebergs in the sea, glaciers and rivers in the mountains and aquifers in the ground. Distribution of water. Over 2/3 of the Earth's surface is covered with water. Of this, 97.2% of water is contained in the 5 oceans in the world. This leaves only about 3%, 2.8% precisely, fresh water that is suitable for consumption by all life forms on the earth. Some 2 million cubic miles of water lies below the surface of the earth, and is called groundwater. About 3,100 million cubic miles of water is found in the atmosphere in the form of water vapor. About 2.14% of total global water is held in polar ice caps and glaciers. When the rain falls on the earth, nearly 60% of it flows into ocean, rivers, lakes and ponds, 10% evaporates and the remaining 30% soaks in the soil and reaches certain distance below the soil to form groundwater. Uses of water. Water usage varies from areas to areas. Water use depends on the purpose for which it is being used. Water is used for many purposes such as irrigation, domestic use, and industry, to generate electricity. Nearly 70% of water is used in agriculture, mainly for irrigation. Lots of water is needed to grow crops. It is estimated that 3 cubic meters of water is needed to grow 1 kilogram of rice. The use of water is about 22% for industry, while for electricity, water is used across the world and accounts for 19% of the total electricity production. Water resources in India. Himalayas in the Indian subcontinent is the largest source of water with 600,000 square kilometers snow-bound area during winter. It has permanent snow in glacier region. From the permanent ice masses originates 19 major river systems of Ganga, Brahmaputra and Indus. Besides, there are 44 medium and 55 minor river systems that are formed from major rivers like Ganga, Indus, Brahmaputra and Godavari. Among all the rivers, Brahmaputra, Ganga, Mahanadi and Brahmani are perennial, i.e. they flow throughout the year. India has only 4% of the world's freshwater resources. The average rainfall in India as a whole is 117 centimeters in a year. It is less than 20% in parts of Thar Desert, more than 200 centimeters in eastern India, and between 50 and 200 centimeters in the rest of India. Though the annual flow of Indian rivers is about 1,869 billion cubic meters, only 36.92% of it is available for use. Thus, more than 91.5% of the surface water flows into seas. So far only 37% of the groundwater resources utilized. Searching dictionary. Land. A natural resource for all life forms on the earth. Soil erosion. Decaying of topsoil by wind, water or human activities. Sheet erosion. Removing soil as a thin sheet or a layer from the surface of the earth, called shear erosion. Soil conservation. Protecting of soil from chemical as well as physical deterioration. Leaching. Water washes out soil nutrients. Water conservation. Scarcity of water is a major problem in many parts of the world. Most of Africa, West Asia, South Asia, parts of western USA, northwest Mexico, parts of South America and Australia are facing considerable shortage of fresh water. In part, this scarcity has been caused by the tapping underground water, increasing demand for irrigation and consumption, polluted water, etc. The situation is made worse by other factors, like unequal distribution of rainfall. Global warming, changing in rainfall pattern, the drying up of water sources and water pollution, over-exploitation and wastage due to negligence. Conservation of water today is therefore a global need. Watershed development. A watershed is a geographic area that drains to a common point. This feature makes it ideal for soil and water conservation. A watershed may comprise one or several villages. In India, watershed development programs have been started under Common Approach for Watershed Development. Communities participate in this program. The program includes afforestation, drainage line treatment, pasture development and improving agriculture production of the rain-fed areas. Dr. C.H. Hanumantha Rao in 1995-96 guided the program of watershed development. Enrich yourself. Question 1. When do things boil? Answer. Things boil from liquid to gas when they reach boiling point, which is the maximum temperature a liquid can reach for water. This is 100 degrees Celsius. Question 2. When do things melt? Answer. Things melt from solid to liquid on reaching a temperature called the melting point. Each substance has its own melting point. Water is 0 degrees Celsius. Leads is 327.5 degrees Celsius. Question 3. Unfold mystery of clouds. Answer. Clouds form when rising air gets so cold that the water vapor it contains condenses into water droplets. Question 4. When do things freeze? Answer. Things freeze from liquid to solid when they reach the freezing point. Most substances get smaller when they freeze as the particles pack closer together. But water gets bigger as it turns to ice, which is why frozen pipes burst in winter. Word to know. Land is a major form of the lithosphere. It provides most of the substances which are necessary to support of life. Land is used for different purposes such as cultivation, grazing, mining, setting up of industries, settlements, and so on. A vertical section of soil from the surface to the parent rock is the soil profile. The Indian Council of Agriculture Research, ICAR, has classified the soils found in India into 6 groups. Soil conservation is necessary for increased agriculture production. Over 2/3 of the Earth's surface is covered with water. In part, the scarcity has been caused by tapping the underground water, increasing demand for irrigation and consumption, polluted water, etc. In India, watershed development programs have been started under Common Approach for Watershed Development.